The first step, selection of a set of molecular structures and their related property or activity. To get more suitable and applicable Qspr Qsar model, we must check the molecules and the target values. The molecular structure and the target values should be correct. No error in bonds, atoms, or groups. Remove the doubt structure and duplicate structure and inorganic chemicals. Finally, chemical structure optimized by using HyperChem or Gaussian software. The second step, calculate descriptors of molecules. Different types or different classification of descriptors, constitutional descriptors, topological descriptors, geometrical descriptors, electrostatic descriptors, charged partial surface area structural descriptors, molecular orbital related descriptors, quantum chemical descriptors. One or more descriptors can explain the physicochemical property or activity of the related compound. Classification of molecular descriptors. Descriptors can be classified according to its origin. Experimental descriptors like log-B, solubility parameters, refractive index, electrical conductivity, NMR. Calculated descriptors can be calculated using software like Dragon and Gaussian. Classification of molecular descriptors according to dimensionality of the chemical structure. 1-dimensional, 2-dimensional, 3-dimensional. 1-dimensional constitutional descriptors like number of atoms, bonds, molecular weight, fragment count. 2-dimensional descriptors, topological descriptors, based on the graph representation of the molecule, connectivity between atoms, group, chain branching. 3-dimensional geometrical descriptor. The descriptor represents the Cartesian coordinates x, y, z for each atom. Back again to the constitutional descriptors. Constitutional descriptors may be molecular weight, total number of atoms in the molecule, or relative number of atoms, like number of oxygen divided by the total molecular weight, total number of bonds, number of rings, number of hydrogen atoms, functional group. All this called constitutional descriptors. 2-dimensional descriptors, that's called topological descriptors, based on connectivity indices, size, degree of branching, neighborhood atoms, Strick effect, flexibility. The most important topological descriptors, Wiener index, depends on the path between the two pairs of atoms. Randic molecule depends on the connectivity between the atoms. Current-Hall index depends on the valency connectivity indices. Mean information content depends on the class or category of the atoms. Wiener index defined as the shortest path connecting a pair of atoms. Suppose we have two structures, two analog, one straight chain and the other branched chain. We can differentiate using Wiener index. Give two different values. For the upper chain, we assign number of atoms, carbon atoms, 1, 2, 3, 4, 5, etc. Summation, the distance between 1 and 1, 0. The distance between 1 and 2, 1. The distance between 1 and 3. The distance between 1 and 6, 5. Summation of these values give us 15. The same for the atom 2. The distance between 2 and 1, 2 and 1, 1. 2 and 2, 0. 2 and itself, 0. 3, 1, 2, it gives us 11. Summation of the obtained values give us 70. Divided by 2 give us Wiener index value 35. In case of the same analog isohexane, the distance between 1 and itself, 0. The distance between 1 and 2, 1. The distance between 1 and 3, 2, etc. The distance between 1 and 5, 4. The distance between 1 and 6, 3. Summation, each row, and the obtained values, the obtained numbers, give us summation 62. Divided by 2 give us Wiener index value 31. By this way, by Wiener index, we can differentiate between branching, isomer, and etc. Under the name of connectivity index, branched index, it can be called a branched index. It's suitable for measuring the extent of branching of the carbon atom skeleton of saturated hydrocarbon. Look at, we have two structures, different branching. In the upper structure, there are 5 atoms, 4 bonds. The edged atom connected by 1 bond. This carbon connected to 3 bonds, and that one connected to 2 bonds, and the terminal one connected to the 1 bond. Run the molecular connectivity index 1 by square root of 1 and 3. This bond connected. The second one, the same, 1 multiplied by the square root 1 multiplied by 3. This bond connected between 2 atoms, 1 3 bond, and the second one connected to 2 bonds. The last one, this atom connected to the 2 bonds, and this atom connected to 1 bond. Give us Randic index value 2.3. In case of other, it gives us 3.7. By Randic connectivity index, we can change information into numbers. It's helpful to the program to deal with these numbers. Current Hall index, that's called valency connectivity index. It depends on the valency of atoms. Look at this equation. Current Hall index is equal to, this is the number of valency electrons. This Z is the total number of electrons. HK, its number of hydrogen. Current Hall index can be utilized to differentiate between primary, secondary, and tertiary carbon atoms. Look at this. CH3 carbon contains 6 electrons. The valence electrons 4. Number of hydrogen 3. It gives us 1 for the primary current Hall index value. For methyl group, it gives us 1. For the secondary CH2, give us square root of 2. Here, give us square root of 3. By current Hall index, we can differentiate between the primary, secondary, and tertiary carbon atom. The algorithm of the AIC index transfers the information of the atoms of the same class into numbers. This structure containing 4 classes of atoms. Carbon, 4 carbon. The terminal hydrogen, this is the second class. CH2, the same class, 4 atoms. The terminal 1 to H2. When we apply this information for carbons, 4 atoms, divided by the total number of atoms in the molecule, log to the base 2, the same 4 divided by 13. It can be done for the rest of the category. It gives us numbers. Any chain or group or sided chain or atoms can be transformed into numbers.